Okay guys, welcome back to another video. Today we are going to prove that if a is an odd integer, then 32 divide a squared plus 3 times a squared plus 7. Now, now trying to let a to be an odd integer. So we start with the proof and then we let a be an odd integer. Now, which odd number that you want? So if you start with a equal to 2q plus 1. Okay, so let's say you have 2q plus 1. What happened to a square? It's going to be 4q squared plus 4q plus 1. And then you have this term a squared times a squared. So for a squared times a squared, which is a to the fourth, the front term becomes 16q squared, right? Okay, and many terms. Okay, oh sorry, it's 16q to the fourth. So for this one, I think 2 equal to a equal to 2q plus 1, which is odd. For this one, we are unable to show that the product of this term is divisible by 32. Why? Because this is 16. So it doesn't have 32 as a factor. So we need larger number in the front of a. It might be 4. Okay? It might be 4. So try to use number 4. So we have to consider a, which is an integer. Okay, let's consider a and 4. Okay, so by division algorithm, what do we have? By division algorithm, so there exists integer q and r, which are integer such that a equal to 4q plus r, where r is greater than or equal to 0, less than or equal to absolute of 4, which is 4. Oh, less than just absolute 4. Less than 4. It must be less than the divisor. So now, what do we have right here? We gotta have a equal 4q, okay? In the case where r is 0, and a equal to 4q plus 1, a equal to 4q plus 2, and or a equal 4q plus 3. Okay, all these must be connected by or. Okay, so we need to choose a so that a is odd, which is this one and this one. Okay, so a must be 4q plus 1. So I'm gonna say that since a is even, since a is not even, is an odd integer. Since a is an odd integer, the possible terms of a can be a equal 4q plus 1, or a can be 4q plus 3. And then we split into two cases. So let's go to the first case. For the first case, we gotta have a equal to 4q plus 1. So what happened in this case? For this case, we will try to show that a squared plus 3 times a squared plus 7 is divisible by 32. So let's start with a squared plus 3, a squared plus 7. So we're going to have a to the 4, 10a squared plus 21. And then what do we have here? We can have 4q plus 1 to the 4. plus 10 times 4q plus 1 square plus 21. Okay, and then you will use binomial expansion to this term. So do not forget that when you have binomial expansion. What is binomial expansion? So you're gonna have a plus b raised to the power of n, which is the summation from r equal to 0 to n choose r, a raised to the n minus r, b to the r. Alright, and what is n choose r? N choose r is n factorial over r factorial times n minus r factorial. Okay, right? So that's what we have. This one, r must be greater than or equal to 0, less than or equal to n. All right. So now let's plug in. Let's expand this term. Okay, for this one, we use binomial expansion here. So we gotta have the sum from r equal to 0 to 4, and 4 choose r, and 4q raised to the 4 minus r, and 1 to the r, okay, and plus 10 times 16q squared plus 8q plus 1 plus 21. Now try to expand this term. So what do we have here? We gotta have 4 choose 0, 4q. So it's just 4q to the 4. Okay, when r is 0, 1 becomes just 1. And next we gotta have 4 choose 1, 4q minus 3, because when r is 1, you're gonna have 4 minus 1, so you're gonna have 4q raised to the power of 3. Plus 4 choose 2, you have 4q squared. You're gonna have 4 minus 2, so it turns out to be 4q squared. And 1 square is just 1. And next is 4 choose 3. You're gonna have 4q, right? So we're gonna have 4 minus 1, which is 4 minus 3, so it turns out to be 1. Okay, and the last one is 4 choose 4, and then we gotta have 4q raised to the 0. So we're gonna have r right here, 4 right here. Okay, expand 10 into this term, so we're gonna have 160q squared plus 80q plus 10q plus 21, and try to simplify these 5 terms. So now try to calculate n choose 0. We have 4 choose 0. I try to calculate n choose 0. N choose 0 is n factorial over 0 factorial n minus 0 factorial. So these are the same numbers, right? So we got to have n factorial. 0 factorial is 1. N minus 0 is n factorial. So n factorial over n factorial will be cancelled. So it turns out to be just 1. Okay, so this term is now 1. Okay, and what about n choose 1? So we're going to have n factorial over 1 factorial n minus 1 factorial. The numerator becomes n times n minus 1 factorial. 1 factorial is 1. So you're going to have n minus 1 factorial in the denominator. So it turns out to be just n. Okay, for next term, n choose 2. What is n choose 2? N choose 2 is 4 factorial over 2 factorial, 4 minus 2 factorial. So you're going to have 4 factorial over 2 minus 2 over 2 factorial times 2 factorial. So numerator becomes 24 over 4, which is 6. And 4 choose 3. I forget to give you this. N choose R equal to n choose s if and only if r plus s equal to n. That means that you're going to have N-3 equal, sorry, that means that you're gonna have 4-3 equal N-1, and N-0 equal 4, sorry, 4-0 equal 4-4. Alright, that means that you gotta have this. After we calculate the combination or N-R terms, this term is now 1. Okay, now 4q to the 4th, 4 to the 4 is, okay, 2 to the 8 is 2, 5, 6 q to the 4. Okay, plus this one is 4, and we have 4q, q, and we have 4 times 4 to the 3, so you're gonna have 3, 5, 6 q cubed, plus this is 6 times 16, right? So you're gonna have 6 times 16 q square plus 4 times 4q. Okay, 16 q. What about this one? Just 1. Okay, just 1. And plus 160 q square plus 80 q plus 30, 31. Okay, so can we find the factor of 32? Or can we find 32 as a factor of this term? So let's try to simplify all the terms. So we're gonna have 3, 5, 6 q to the 4 and 2, 5, 6 q cubed plus 96 q square plus, okay, 16q plus 80q. So you gotta have, okay, 96q plus 160 q square plus 32. Okay, and then what can we do next? So you're gonna have 3, 5, 6 q to the 4, 2, 5, 6 q cubed, and add this term, so you're gonna have 2, 5, 6 q square plus 96q plus 32. It seems that all these terms have factor of 32 because 2, 5, 6 is 8 times 32. So we gotta have 32 times aq to the 4 plus aq cubed plus aq square plus 3q plus 1. Alright, and the sum of this number is an integer. So we can see that this term right here, a squared plus 3 times a squared plus 7 is has 32 as a factor. So in this case we have shown that 32 divide a squared plus 3 times a squared plus 7. Alright, now let's go to another case, the case where a equal 4q plus 3. Okay, take a look at this case. Another case is a equal to 4q plus 3. Okay, so what can we do with this? So we have to start from a squared plus 3 times a squared plus 7. Okay, and then we expand this term, so we're gonna have a to the 4 plus 10a squared plus 21. And then what do we have? We plug 4q plus 3 into this a. So we're gonna have 4q plus 3 to the 4 plus 10 4q plus 3 square plus 21. And then we use binomial expansion to deal with this term, right? So we gotta have the summation of r equal to 0 to 3, 4 choose r, 4q 4 minus r, 3 to the r plus 10 times. Expand this term, so you're gonna have 16q squared plus 24q plus 9 plus 21. Now try to expand this term. So what do we have right here? Okay, let me move this one to the left side here. So we gotta have 4 choose 0, 4q to the 4, okay, because r is 0, plus 4 choose 1, we could have 4q cubed, 3 to the 1, okay, plus 4 choose 2, we can have 4q squared, 3 squared, plus 4 choose 3, we gonna have 4q to the 1, 3q, plus 4 choose 4, 4q to the 0 is just 1, right? And then we can have 3 to the 4, plus this term. So what do we have? So it's going to be 160 squared plus 240q plus 90 plus 21. Okay, so NT0 is 1, right? This is 1. This is 256q to the 4th, okay? 256q to the 4th, and this one 4 times 4q is 4 to the 4 is 256q, okay? 256q cubed times 3 plus 6 times 16q squared times 9 plus 4 times 4q plus times 27, and 4 choose 4 is 1, okay? 4 choose 4 is 1. This term 4q squared, 4q0 is 1. 3 through 4 is 81. This term is 160 q squared plus this term 240 q plus this term is 111. Okay, so you're gonna have 256q to the 4. This term, what is it? I will leave number 3 right here. I'm not gonna multiply this number. So you're gonna have 3 times 256q cubed. And this term, okay, this one is interesting because we have 56 plus this term, and this term is 16 times 10 q squared. This one is 54, okay, 16q squared. So we gotta have 64 16q squared. All right, and the term with 10, or the term with q, for this one right here, what do we have? So I think we need to add these terms. Okay, let me calculate this one. So what do we have here? Okay, let me think. 16. Okay, what is this one? Okay, give me a second. This is 16q times 27, okay, 16q times 27, and this one here is 16q times 15, right? Okay, is 160. 5 times 60 is 80. It's 80. Okay, great. So we sum this term. So you're gonna have 42. Okay, 42 16q plus 81 plus 111. So you're gonna have 192. 192. Okay, that's what we have. And we factorize 32. So for this one, we gotta have Okay, 32 times 8 cubed to the 4 plus 32 times 8, okay, times 3 times 8, sorry, cube plus 32. For this one is 32 because we have 32 times 2 because with this is 64. So we gotta have 32 times 32 cube square plus this one right here. We gotta have 21 times 32 cube, right? So it turns out to be 32 times 21 cube plus 32 times what number? 192 times 6. Now we can factorize 32. That means that we can have 32 times 8 cubed to the 4th plus, okay, 3 times 8, which is 24 cube plus 32 cube square plus 31 cube plus 6. As you can see, these are the sum of integers. So they will be, so this term is going to be an integer. That means that 32 is a factor of this term. Okay? That means that 32 divide a squared plus 3 times a squared plus 7. Okay? Therefore, we have shown that 32 divide a squared plus 3 and multiply by a squared plus 7. Okay, so from these two cases, when a are odd numbers, okay, this is the odd number in the form that has a remainder of 1 when it is divided by 4. And the second case is an odd integer that has remainder of 3 when a is divided by 4. So we have shown that from both cases, 32 divide a squared plus 3 times a squared plus 7. And that's it for this video.